Hi everyone, so in this video we are going to be talking about Simplex. So Simplex is going to be our newest method to be able to solve these maximization problems that we've been doing. So first off, a Simplex tableau is going to look kind of like a matrix with some differences that we're going to go over, but that's the thing that's going to actually let us use the matrix row operations to be able to find that maximum. Also, the other definition we're going to need is a basic variable is a variable with only one non-zero element in its column. And I'll show you what that means in a minute. We're usually going to put these on the left of the Simplex tableau, that way they're nice and easy to spot at any time. Only these variables have values. Non-basic variables are 0. So whenever we actually set up the tableau, we're going to come back to that and explain exactly what that means. But for now, we're going to go ahead and start with example 1, just so we can see how to set up the Simplex tableau, find something called the pivot, and state the entering and exiting variables, which are going to be how we deal with those basic variables. Okay, so first step, before we can actually set up the tableau, is going to be to turn this I system into an E system. So remember, that just means we're going from the inequalities to equations by adding slack variables. All right, so if we take that first constraint, it's going to be x1 plus x2 plus s1 equals 20. Then we have 2x1 plus 12x2 plus s2 equals 60. Remember, the last one we just add on the slack variables, so x1, x2, s1, s2 all are going to be greater than or equal to 0 now. Now, one extra thing that we're going to do is we are actually going to take this and we are going to set it equal to 0. So we're going to take the profit function and we are going to set it equal to 0. Specifically though, we want to move all of the x1s and x2s over on the side with p. So we want p to remain positive. So all that means is that we are going to be subtracting 5x1 from both sides, so minus 5x1, subtracting 10x2, so minus 10x2. P stays there, so plus P equals 0. Right? So we're just changing the signs of the variables that were on the right to be able to move them on the left with P. Once we have that, we are ready to actually set up this tableau. So first thing we're going to need, just to start getting the basic shape, is we're going to need all of our variables and a space for those numbers like the 20 and the 60 that are on the right side. So just to make some columns, I'm going to write all the variables, so x1, x2, s1, s2. Now we have one more variable. We actually have p. We are going to need that. And then I usually just put the symbol for the numbers that are on the other side. This is going to let us set up our tableau. We are going to need 3 rows because we are going to need to put this, this, and this into the tableau. Now, we put the constraints first. So these two are going to go first. And whenever we're putting them into the tableau, we literally are just going to treat it like making an augmented matrix. So how many x1s do we have there? 1. How many x2s? 1. How many s1s? 1. How many s2s? 0. No p's either. Then we're going to put a line, and the 20 is on the other side of the equals. So just like setting up an augmented matrix. Same thing for the other constraint. So for this one we have 2x1s, 12x2s, 0s1s, 1s2, 0p's, and a 60 on the other side. Lastly goes that profit function. So just to separate them out, I like to make a dotted line right there, just so we can easily tell that stuff on the top of that dotted line were the constraints, stuff underneath it, that was the profit function. So we have negative 5x1s, negative 10x2s, 0s1s, 0s2s, 1p, and a 0 on the other side. On the left-hand side of this are going to go our slack variables and p. So we start off with s1, s2, and p on the left-hand side. And that is our simplex tableau all set up. It's essentially just a matrix that holds both our constraints and our profit function all at once. Okay, so remember I said there was those basic variables? So the basic variables are actually shown right over here. So right now our basic variables are S1, S2, and P. Those are the only ones that actually have any type of value currently. And if we did want to know their value, all you have to do is go all the way over to the right, and that number right there tells you what that variable is. So what I mean by that is right now, S1 is 20, S2 is 60, P is 0 because all the way to the right there is a 0. But what about X1? What about X2? Well, since they're not on the left, those are non-basic variables. So remember when I said non-basic variables are 0? That means both X1 and X2 are automatically 0 currently. Only variables that are on the left actually have any kind of value. All right. Now, the variables up top, these up here, are never going to change. That's just literally telling you what each column represents. Those labels are going to stay the same. The ones on the left are actually going to change as we go through the process. Right? And that's where the entering and exiting variables come in. What we're basically going to do is we're going to take one of those variables out and we're going to replace it with a different variable from the top. So for example, we might end up replacing S1 with X2. We might swap those out. So whenever a variable exits the left side, we call that the exiting variable. When a variable enters, we call that the entering variable. And whenever we go through the whole process of Simplex, you're going to see that in more detail, and we're actually going to do that process. For now, we just need to know how to figure out which one is going to enter and which one's going to exit. Okay, that's where the pivot comes in. The pivot is the biggest thing that is different between this and Gauss-Jordan. So we almost have something that looks like a solved Gauss-Jordan already. I mean, we have our ones in our diagonal. We have the zeros above and below it. So that's pretty much already just like Gauss-Jordan. So we're not looking for a specific goal this time where we're trying to say, make a 1 in the top left. We don't know where our 1 is going to be. That's what the pivot is going to be. Our pivot is figuring out which number needs to become a 1 next and have zeros above and below it. Okay, so to find the pivot, we're going to do this in 2 steps. First, the column. So the column is going to be pick the column with the negative number with the highest absolute value on the bottom row. So what I mean is we're going to look at the bottom row, and specifically we're only going to look at the negative numbers. So the -5 and -10. Pick the one with the highest absolute value means if you ignore the negative, which one's bigger? Well, 10 is bigger than 5, so the -10 is the one we're looking at now. That means we are going to pick the column with the -10 in it. Next up, the row. Divide each number on the right by the number in the column you just picked. Pick the row with the smallest result. Okay, so what I mean there is we are going to take the numbers on the right side, except we can ignore the one on the bottom. Our pivot will never be in the bottom row, the P row. So just the 20 and the 60, we're going to look at those, and we're going to divide them by these numbers, the numbers in the row that we already picked. So we're going to divide 20 by 1, get 20. We're going to divide 60 by 12 and get 5. 5 is the smaller one, so we're going to pick the second row. Our pivot is the number where those intersect. So in this case, the pivot is the 12. All right, so we found the pivot. Again, for this one, we're not actually completely solving this problem, so you don't have to know what to do with it quite yet, but we have found the pivot. All right, next step. It says state the entering and exiting variables. We've already done all of the hard work for this. Whatever variable is in the column that you picked, that variable will enter. So x2 is our entering variable. Whatever variable is in the row that you picked is going to exit. So S2 is our exiting variable. And that's it. We've completed all of these steps, and we would be ready to start solving this simplex problem now. And in particular, to solve this, we would end up using row operations to still make those ones and zeros like we were doing for Gauss-Jordan. All right, let's try just the setup again though, and finding the pivot and stating those entering and exiting variables. So example 2, set up the simplex tableau, find the pivot, state the entering and exiting variables. So remember, first thing, turn the I system into an E system. So we're going to have 7x1 plus 9x2 plus s1 equals 21. Then 14x1 plus 12x2 plus s2 equals 28, with x1, x2, s1, s2 all greater than or equal to 0. All right, again, then we need to do the profit equation. So we move the x1 and x2 to the other side, giving us negative 27x1 minus 19x2 plus p equals 0. Now we're ready to go ahead and get this stuff into a tableau. Start with all of your variables across the top. x1, x2, s1, s2, p, and the number. And keep in mind, if you do have extra variables, as in if you had a third inequality, you would have an S3. You would just put it on top. Or if you had a third actual variable, as in x3, you would put x3 on the top. You just put all of your variables that you have, plus p and the number that's on the side. All right, so if you start putting everything into it now, we start with the constraints. So again, we're going to start with the 7, 9, 1, there's no S2s, no P, and 21 will go on the side. Second constraint is 14, 12, 0 S1s, 1 S2, no P's, and a 28 on the other side. Put a dashed line, and then our profit function. So negative 27, negative 19, 0, 0, 1, and 0. On the left, we have S1, S2, and P. And remember, the left-hand side is always going to start with the slack variables and P. Always. Cool, so now let's go ahead and find the pivot. So for our column, we look for the column with the negative that has the highest absolute values. So remember, look at the negative numbers, and if you ignore the negative, which one's bigger? Well, that's going to be the negative 27. So that's going to be our column. Next, for the row, we are going to take the numbers on the right and divide them by the numbers in the column that we just found. That means we're going to be dividing the 21 by 7, getting 3. We're going to divide the 28 by 14 and get 2. Then we pick the row with the smallest, which was the 2. So that's going to be our second row. Our pivot is wherever they intersect. So in this case, it's the 14 that's right there. All right, lastly, entering and exiting variables. The entering variable is the one in the same column that you picked. And the exiting variable is going to be the one in the same row that you picked. So x1 is going to enter, s2 is going to exit. All right, now that's this problem done. I just want to say a couple more things about a pivot. A pivot, it must be a positive number. So no negative pivots, right? So if you ever end up getting a pivot that's negative, just pick the other row instead, right? For this class, that's the only catch, is it must be positive, and it also can't be 0 either. Right? In both these cases, that absolutely didn't happen, so we are good, but just a little note in case it comes up, your pivot cannot be negative or 0. All right, with that said, I'm going to leave this video here. In the next video, we are going to actually start trying to solve one of these. So we're going to do this exact same process, which, if you noticed, our second example did get a bit faster without me having to explain every single step. So it does get faster, I promise. But we're going to do all of this, and then we're going to continue on and see what we do with that pivot now, and how this is going to actually lead us to the answer to this maximization problem. Because that's our end goal here, is to actually answer that question of what values maximize p. All right, so with that, I will see you in that video. Thank you.